This is the section that I think every one of my students that I have taught over the years, when they hear the word sums, the mind just goes and it shuts down, right? In most cases, not every one of you are like that, obviously. But generally speaking, people who are very good at maths, the word sums are killers for them, right? Now, what I want to do is I want to go through a few of these. As I've said, I'm combining grade 10 and 11 here. I'm going to do grade 10 problems and grade 11 problems at the same time. The reason being is that I want to do it properly and get a good foundation basis for it, because once you see what types you've got, okay, and the methods of solving, they're quite simple. They're just a recipe. However, okay, let's just see what types of mathematical modeling problems are we going to do. So, oops, got it on green. Let me put it back to black. So let's have a look here. What types of problems do we have? Types of, I'm going to call them types of models, right? And yes, I know you get hand models, foot models, whatever models, but these are mathematical models. Right, let's, first of all, we get the age or number. Okay, number 2, we get financial. Number 3, we get speed. Okay, and we get area and volume. Okay, so we get age or number problems, financial, speed, area, and volume type problems. Okay, I know there are rate problems. I'm just going to do these first as a section. Right, what do we need to do? First, let's look at some revision issues. Let's just do a quick revision. Okay. When you read these number problems, okay, in fact, a few days ago, it was a Sunday, some students were in, 2 girls were in, they're in grade 8. I was teaching them maths. And word problems, these age problems came up with them, right? And it was quite fun in a way. But what you do with this is you say, when you read it, all the information is hidden in the reading. You will see words. When you read it carefully and you say, okay, when you get to translate it from the English to the maths, you look for a word like this. These are the words that we're going to see. This is the words English. And this is the translation into maths. Okay. We see the word product. What do? It means I multiply. The sum. Translation, I add them. The difference, it means I subtract. The quotient means I divide. I've just put it in here. The times itself, times by itself, means it is squared. All right. So, other things. Here's another one. All right. Consecutive numbers. Consecutive numbers. In English, that's that. In maths, that means x, x plus 1, x plus 2, x plus 3, etc. All right? This is where it throws a lot of people. Consecutive even. What does consecutive mean? Consecutive means the one following the other one. That's what the word consecutive means. It means they follow the next one on. Consecutive even numbers. Consecutive even numbers is x plus 2, x plus 3. X plus 4. I was still in the previous mode. X plus 4. All right? And consecutive odd numbers is the same. Okay? Right. Now, how do we go about these problems? Okay? First of all, okay, number one is to say, read carefully. Read and translate into maths. Right? So when they say the sum of, you put a little plus sign down. A number. Words like a number. How old is somebody? This is X and that is X. When they look through the question and when they say and give you how old is Jane, let's say, or how old is Peter, right? Or a certain number is, that's the one you call X. That's the variable. That's what we're looking for because they're going to ask us, what is that value, right? So the one we do is that we say, right, read and translate into maths roughly first and then write the equations down, right? I would say to you, do this as soon as possible. And I'm going to put this down as, just want to check, what did I call that? Number 1. Okay, and number 2 here is going to be number 2. Draw it. Where possible, draw it. Okay. If they tell you a boat goes from A to B, put down A, B, and put all the information they tell us. It could be 100 kilometers, and they tell you it sails at 25 kilometers per hour, etc. Right? You put down all the information onto your diagram. Why? It shows you clearly what's missing. Remember, a picture is worth 1,000 words. That is critical. It helps you to understand, but not only understand, it also puts the whole problem in a picture, which is then you don't have to remember everything in your head. It's all in front of you, right? You don't have to go looking for speeds or directions or anything else. It's all put down in front of you. Okay? Now, number 3, okay, is identify the type, and use the table. The tables that we're going to talk up now. And into the table, insert all info given into the table. Right? Insert all the information that is in the sum into the table. Okay? And fill in gaps. Okay? Right? This shows you what is missing and it helps you to organize the data in the problem. Right? Okay? Be clear what you're being asked for. Okay? It's not really a heck of a difficult thing, but when you've got the table, it jumps out at you, or a drawing, it jumps out at you what you've got to do. Let us look at section A, which are age type problems. Let's look at age problems. This is the typical problem here. They usually use 2 people, right? A father, son, mother, daughter, niece, nephew, 2 friends. There's usually 2 people, right? So what I say is right, my table is put down what situation it is, okay? I call this the scenario. Okay? And we put down person A and person B. Either they call them A or B, or they call them dad, son, or they call them John and Peter, or John and let's take it like this. Maybe they call it John and Claire, right? You put down the person, because that focuses the mind on, are we talking about person A or person B, right? The next step, that's the scenario, we put that down. Then they tell us, now, this is currently, it's the now situation, right? What are we saying? We put down the information about this person and this person now, right? Then they're going to say time marches on. So we put in either here future or past. Okay? This has moved on by so many years. Okay? All right? I'm going to do an example straight after this. All right? Now, then basically what we're going to do is we're going to solve for the missing bits. Okay? Let's do a practice example, shall we? Okay. I'm going to write down the example as it stands. John is 3 times older. Okay, here we go. Example 1. Well, I don't generally number my examples, but we'll do a few. John is 3 times older than his son. Okay. John is 3 times older than his son. Okay. Then they say in 12 years' time, okay, he will be twice as old. Okay. How old is John? Okay. Well, what did I say we do? First thing is when we read through it, we say John and his son. So it's an age problem because they're talking about years old, right? So age problems, I say, right, I go to it and I put down my scenario over here. Right, so we've got John, who is the dad, and we've got the son. I put down the information for now, right? What did they say? Look here, look at this. How old is John? That's X. John, the dad, is X. Okay? And they say, well, John is 3 times older. 3 times means multiply. Now, if you're unsure what to do here, what we do is this. You say, okay, let's say the dad is, I don't know, say for example, the dad is 30, okay? We've picked an arbitrary number. It's not the answer. We're just trying to work out as an example, we're choosing a simple number. So according to the English, John is 3 times, dad is 3 times older than son. Therefore, son must be 10. I had to divide it by 3. So over here, this is x over 3, right? That just helps me to get the maths in my mind. Okay, that's all it does. Okay, so this here is not related at all. All right, this is not related, not the answer. It's just a way of helping the maths. The next step is we put in future or past. Okay, what do I mean? They tell you in all of these sums, in 12 years, they've said, from now to the future is plus 12. So how old is the dad in 12 years? If he's 30 now, he's going to be 42, which means we've added 12. X plus 12. which means the son, he's now x plus 3. We also have to add 12 to him. Okay? This is in the future. If they'd gone back in the past, the dad would then be past. Okay? It would be x minus 5 years, let's say. All right? So that's how the past is the current minus how far past. The future is the current x plus so far into the future, right? Then the last thing they say to us is they say, okay, right? What are the ages here? All right? Well, we don't know, so we're going to have to go and work it out. Okay? How do we do it? Well, we say, look at the information in 12 years. So now, over here, at this point, okay, the dad will be twice as old as him. Okay? So what does that mean? Well, if the dad was 60, okay, I'm using different numbers, this guy here would be 60, would be 30, because the dad is twice as old. So what I took this age, x plus 3 over 12, and I multiplied it by 2. Okay? Right? We took the age and we multiplied it by 2. Okay? Have a look what I've done again. It's therefore 2 times x over 3 plus 12 must be equal to x plus 12. Okay? Right? 2 times that must be equal to, because they said that he's going to be, how old is John now? Okay? And in the future, he'll be, John is 3 times, it'll be twice as old as him. Right? So therefore, we've got that. And what can we do? You can go and solve these and you work out x. Okay? So what we're doing is we're looking at the information and we're putting it into blocks of now and future. Okay? If you take it to the conclusion, you're going to be finding somebody's age now, because what we want is x, which is the red one, which is now. Right? Let's take another one. All right? Let's take this. Okay? Okay. Twice it. Okay, if the sun, yes. Let's take the next one here. Right? Example 3. 3 people have ages that add up to, well, let's just write it down. Okay. Okay, example. Let's see here. Ages that add up to 64. So what's our situation? Okay. Let me just write it out in full. Right? I don't want to. They say to us 3 people have ages, okay, that add up. Already maths, we're saying that's a plus. Add up to 44. 2 means equal 44, right? Okay. A is twice the age of B, and so, right. So now we put down our scenario here. Okay. We have A, B, and C. We've got 3 people. Now, okay. And they say, what are their ages? Whoa. That's the scenario. So let's put in here now. Okay. That add up to 44. A is twice the age of B. A is twice the age of B. So straight away, if I call B X, A must be 2 times X. Okay. And B, and 6 years older. Okay. And B is 6 years older than A. Okay, or A is 6 years. A is, sorry, that was my mistake. And A, I've written it as and A is 6 years older than C. All right? Which means, how old is C? C must be 2x minus 6, right? Therefore, right, you can check it out, right? Have a look. Try x equal to 5, okay? This is a test, okay? I'm going to change the color to green because it's not part of the equation. What do? I say here, let x be 5, which means this must be 10, which means this one is going to be 4, right? That's basically, and then we'd add them up and get the sum of the years. So what are we saying? We're actually saying this, aren't we? We are saying that the sum of the ages, they add up. So therefore, 2x plus x plus 2x minus 6 must be equal to 44. So what do? We then rearrange 2x plus, expand the brackets, and you get eventually 5x minus 6 equals 44. Okay, 5x is equal to 50. X is equal to 10 years, right? Therefore, how old are the people? All right, A is going to be 20 years old. B is going to be 10 years old. And C is going to be equal to 14 years old. Okay? So, in all of these situations, right, what do? We look at the maths and it tells us, okay? We put down our scenario here. This is the peeps, A, B, C, or whatever. Put down now, okay? The one that you're given is X. This one is, let's say, 12 years older, right? Then they say in 10 years. Okay, which means how old is this person? X plus 10. And this one is X plus 10 plus, X plus 12 plus 10. Can you see there? What I've done is I have taken this age here and advanced it by 10. All right. Then they'll tell you something about that to link them together. Okay. So when you've got the ages, the secret is to sit down and say, right, put it down now and the future scenario. If it's past, it means you've gone the other way. So then you would go backwards, wouldn't you, for past? So on the age problems, that's the way we do it. Numbers, same kind of thing, right? They are actually even easier because they tell you this number squared plus that number, blah, 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 blah. They are much easier than the age problems. The next session I'm going to do is on financial, which they're often called the shopping type problems, profit, net profits, etc., cost per items. Essentially, we're going to look at the kind of things that's on a bill. When you've been into a restaurant or a shop, you get so many items at so much each equals a total. But we'll deal with that in the next one. So please remember, do one or two of these. Do the one that I didn't finish or do any of them. Okay. Make one up for yourself. Okay. Take a scenario and just make it up. Okay. Cheers. See you in the next one. Have fun with these. They really aren't difficult. Remember, put them down into the table. Cheers. Bye.